Hello, welcome users to my channel Learning with Khatak. We are developing basically a model for heart disease prediction model by covering data science and machine learning. We have delivered four parts of developing this model. In part first, we cover the exploratory data analysis in detail. While in exploratory data analysis, we perform a univariate analysis. What is univariate analysis, bivariate analysis, and multivariate analysis? In part 2, bivariate analysis is covered. In part 3, multivariate analysis is covered. While in part 4, we divide our data sets into train test, and then we create respective models, and then train our model and then fit our model, and finally we predict our models. So if we summarize all the parts, in exploratory data analysis, while performing the univariate analysis, we just look to the target variable. What is the target variable? What is the shape of the target variable? What is the shape of the overall data set sum? How many number of rows? How many number of columns in the data set sum? And then univariate analysis, or feature of interest, since our feature of interest is a target variable, we cover in detail that how our target variable is look like, what are the association of different observation with the target variable. And then in bivariate analysis, we compare the target variable, we find the relations of target variable with different pairs, like the age features, how the age feature is correlated with the target variable, and how a sex feature is correlated with the target variable, and so on. Similarly, then in part 3, multivariate analysis, we generate a heat map to look at the complete correlations of all the features with respect to the target variables. From there, we find that how many features are strongly correlated or positively correlated with the target variable, and how many features are negatively correlated with the target variable. And then part 4, we divide our data sets into train and test sets in the ratio of 20 and 20%. Means we have divided our data sets. 80% data sets is now consist of training samples, and 20% data sets is for testing purpose. And then we create objects for different models like support vector machine, NV, KNN, random forest, decision tree, and logistic regression. And then respectively, each model is trained with the 80% data sets, and then fit the model, and then finally we predict our models by feeding the 20% samples of test data sets. Now in today's part, we actually want to compare all the models, their accuracy, their confusion matrices, to find out what classifiers perform best while predicting whether a patient is a heart disease or not. And then finally we will give an input to our respective models to predict whether the patient have a heart disease or not. So let's start. Okay, so in our last part we covered, we divide our respective data set into two parts. This is training and testing. Let me show that in a quick way. Okay, if you look at this, we divided, this is our train test set functions or procedure, which divides our data sets into two features and target in the ratio of 80 and 20. So if you look at this, we have now in training set 2 samples with 13 features, and test 61 samples with 13 features. Okay. After the training set, this is the shape now. Shape of X train means number of samples in the training set, number of samples in the training. This is basically the target variable. And similarly in the test, these are 61 samples with 13 features, and these are the target variables. And then we fit our model by simply creating a model. For example, this is L, or is a reference object of the logistic regression model. Then we fit here L or dot by using fit method by supplying X train and Y train test sets. We did so for the all the models, and then here we find the confusion matrix by simply matrix dot confusion matrix while supplying Y pred and Y tester. The predictions made by our respective models and the samples in the test sets. So this is the confusion matrix, and this is the precision, respective precision, recall F1 score and support. And this is for the NB, Navy base. And then for SVM support vector machine, KNN snipers, we have covered all these things in part 4. So if you are new for part 5, please look at the part 4 first, then you can understand the part 5. Decision tree and similarly random forest, neural networks. Okay, now we want to put all the output in a files. So these are the basically accuracy scores of logistic regressions, accuracy score of NB, accuracy score of SVM, accuracy score of KNN, and all the classifiers we have created in the part 4. If you look at this, this is RF score of NN. If I show you the last one, that is a score of neural networks. So we get all the accuracy scores, the respective accuracy scores for all the classifiers in part 4. Now in this part, we are putting all the accuracy scores in a file to compare that which one classifier is performing best while predicting a heart disease patient. So these are the different classifiers. I name them. You can name them some in your own convention if you want. Then I simply using a for loop to look at the accuracy, best accuracy. So if I run this, this will give me the complete accuracy of every one. So this is the accuracy achieved using logistic regression, DES, logistic regression, and NB, support vector machine, KNN, decision tree, random forest, and neural networks. Keep in mind, if you run all the model again, it may happen that the accuracy scores may vary a little bit. For example, at this time, logistic regression gave me 85.25. It is possible that in next run, it gave me 84 point something, 85 point something. Anyhow, we will discuss this later. So if we now want to generate a graph to show a graphical comparison between all these, so these are the different classifier logistic regressions, and this is the respective accuracy score. And similarly, NB, support vector machine, KNN snipers, decision tree, random forest, and neural networks. So in all these classifiers, this time a random forest perform a little bit faster, a little bit better as compared to all other classifiers in respect of accuracy only. So here random forest classifiers give good on heart disease dataset as compared to other classifier. Now building a predictive systems. How to build a predictive system? So for predictive systems, definitely we need some input data. Input data, what does it mean input data? If we look at our data sets, just show me here our data sets, df heart dot 2. Just want to show the two observations here. So if you look at this, age, 6, CP, and these are the 13 different features of the data sets. Since we train our model on different samples having 13 features, so for predicting we must supply at least 13 features. At least 13 features to our model. So if we look at this, this is the first feature, which is age. So a patient, this is basically a patient data. A patient of age 55, this is 6 means this is male, and then 3 basically the CP chest pain type, 152 trip TBPS, and then these are the respective different features, but there is no class, so now, because we just want to predict whether how much probability of there that the patient is having heart disease or not. So then after this, change the input data into a NumPy array. So here input data is NumPy array np.array string input data. This input data will be now converted to NumPy array, and then reshape the NumPy array as we are predicting for only one instance, because there is only one instance. If we have more than one instance, then we may use a data frame, a different 2D array, or something else. So then prediction model dot predict input data reshaped. This is the reshaped data that is supplied to predict model. Model is a respective model. Then now here the model will predict the predictions. If I run this code, so this gave me 0.84, means point or model prediction is 84 point correct that this patient has a heart disease. So guys, this this is the last part to predict whether a patient have a heart disease or not. The heart prediction model, or building a heart prediction model, consists of 5 parts. In first part, a univariate analysis, or simply in first 3 parts we perform exploratory data analysis by covering univariate analysis, bivariate analysis, and multivariate analysis. In 4 parts we divide our data set into respective train test set, create the object, create a reference of the classifier, then train the classifier, and then finally predict. In part 5 we summarize all the 4 parts and then compare all the classifiers, and then finally we give input to our model to predict that whether the patient has any heart disease or not. So thank you very much. Hopefully we will come with another video. Here we will cover the multi-classifications problem when there are more than 2 classes in the data set, because in this data set there are only 2 classes, and you can download these data sets from a universal repository, that is Kaggle, or you can even get it from GitHub. So thank you very much.